So we've talked about when functions are increasing, when functions are decreasing, where functions reach local minimums, local maximums, where functions have absolute maximums or absolute minimums. We've talked about vertical asymptotes, we've talked about holes, we've talked about horizontal asymptotes a little bit, types of discontinuity. We're just talking about all sorts of properties that the graphs of these different functions have. Okay? The last property we're talking about right now is symmetry. Okay? And there's really two types of symmetry. There's even and there's odd. But something can be even, something can be odd, or it's not either one of them. It's just neither. Alright? Now, you'll be able to use Desmos so you can kind of look at the graph of a function to determine whether it's even or odd. Okay?
Dusty Schultzen, report to the secondary office. Dusty Schultzen, report to the secondary office, please.
So you can use Desmos to kind of help confirm your answer, but you're going to have to show me algebraically how you know it's true. Okay? So I kind of wrote a couple parts on each one of these. An even function is a function that is symmetric to the y-axis. So that would be something, this is very basic here, but something that looks about like this. Okay? If I were to fold this right along the y-axis, it would match up on the other side, right? Okay? So anything that is symmetric to the y-axis, so if you were to fold the graph right along the y-axis and it would match up, okay, that is going to be an even function. Okay? Now another thing to kind of think about, what type of function is this?
A squared.
An x squared, right? Or a quadratic function? Okay? X squared, that's an even number, right? Okay, sometimes those things go hand in hand a little bit, okay? But don't just assume when you see an x squared it's always going to be an even function, okay? But if you only see even powers, then there's a good chance it is an even function. But this would be an example of an even function. It's symmetric to the x-axis. The work you're going to have to do is you're going to have to show me that if you plug a negative x into the function, you'd get the exact same thing as if you plugged in a positive x. Okay? Which would make sense, right? If I plug in a 1 and I get negative 3, then I bet if I plug in a negative 1, I also get negative 3. I get the same answer whether I plug in a positive 1 or whether I plug in a negative 1. Okay, that's basically what this is saying, but I'll show you how that looks algebraically here in just a second with an example. But this is what you're going to have to show. Basically it's saying if I plug in a negative x instead of an x, I'll get the exact same thing for an answer. Okay? So that's an even function. An odd function is symmetric to the origin. And what I mean by that is, if I would rotate it 180 degrees or flip it upside down, so if you picked up this paper and you looked at the graph like this, would it look any different if you picked up the paper and looked at it like that? Don't they look the same? This way versus this way? Okay? This is an odd function. It's symmetric to the origin, meaning I can rotate it around the origin. I can rotate it 180 degrees, and you can't tell the difference. They'd be hitting the exact same coordinates if you picked the graph up and looked like this, or if you picked it up and looked like this, they'd be hitting the exact same coordinates, not knowing which way was positive or which way was negative. Okay? So that's an odd function. Okay? What does this graph kind of look like? What function? What parent function? Cube, right? Odd power. Not exactly a coincidence. Okay? Alright, so a lot of times you'll see those on your odd functions. So it's symmetric to the origin. It means you could rotate the graph upside down and it would be identical. You wouldn't be able to tell a difference. The work that you're going to have to show me, though, is that if I plug in a negative x into the function, I'm actually going to get the opposite of what I would have gotten plugging in a positive x. Okay? So for instance here, if I plugged in a negative 2 and out came a 5, okay, it would make sense then that if I plugged in a positive 2, out would come the opposite of that, which would be negative 5. Okay, they're just kind of opposites of each other there. But again, I'll show you an example of one where we get even, we get odd, we get neither. Okay? Now, if you have a function that's not even and it's not odd, well, Very basic, it's just neither then. Okay? So when we ask you what type of symmetry does a function have, your answer is simply going to be even, odd, or neither, and you're just going to have to show me algebraically which one it is. Any questions so far? So these are the type of questions you're going to get. Is this function even, odd, or neither? Okay. Now if somebody has Desmos out, you're welcome to quit graph it and take a peek at it, but you don't need Desmos to do it. Okay. What you're going to do is you're just going to see what f of negative x would equal. Okay? If f of negative x equals the original function, then it's even. If f of negative x equals the opposite of the original function, then it's odd. That's all there is to it. Okay? So to do f of negative x, that basically means I'm plugging in a negative x in place of x. Just like if I said find f of 7, wouldn't you just plug a 7 in right here? I know that was a little bit confusing a little bit last week, but you know, if this was my function and I said find f of 3, you would do negative 2 times 3 squared plus 7, and then you see what you get for your answer. Remember that? Okay? I'm just asking you to find f of negative x. So in other words, I want you to take negative x and substitute it into the function. So here's what it will look like. Negative 2, what am I plugging in place of the x? Negative x squared plus 7. Parentheses are vital. You've got to use parentheses around whatever it is that you substitute into the function. Okay? Now make sure you do your order of operations correctly. Okay, order of operations would tell me to do what's inside the parentheses first. Well, that's just a negative x. Then I do exponents. What happens when I take a negative x times a negative x? I get a positive x squared, right? Okay, so this became a positive x squared. So now I have negative 2 times a positive x squared, and then plus 7. Can I simplify that any further? No. What do you notice happened when I plugged in a negative x? What did I get for my answer? How does that compare to my original function?
Same one, so it's even.
It's exactly the same. So because when I plugged in negative x, out came the original function, the same thing, I know this is an even function. So it is even. Now if you looked at the graph of it, it would look something like this. It's an upside down parabola, which you can tell is symmetric to the y-axis.
Can't you just tell that since it's a square, it'd be like a square graph, so it's even and cube is like odd?
Okay? Not all squared graphs will be even. Okay? I'll show you a quick example of one that's not.
Why do you plug in negative f?
Why did I plug in negative x? That is how I prove something is even or odd, right here.
Okay, so you always...
You have to do it, yep. You have to show me that it's even or to show me that it's odd, you're going to see what f of negative x is equal to. If it equals the original, it's even. If it equals the opposite of the original, it's odd. If it doesn't equal either one of those things, then it's neither.
But under the even, you have a negative sign on the x, and on the other part, you don't have a negative sign.
Where?
Under even, that column, you have a negative sign right there, but not on the x right next to it when it comes to equal.
Okay, this is saying when I plug negative x into my function, it will equal the original function. F of x is my original function.
Okay, so it won't be the exact same because it won't have the negative.
Somebody help me out? I'm not quite following what you're saying.
She's saying, like, why do you have it equal to f of x?
The negative x is what you plug into the function to try to get the original function. To prove that it's like
Okay.
To prove something is even, it's saying if I were to plug in a negative number, now I'm not going to sit here and plug in every negative number in the world. That would take too long. That's why I'm using negative x, right? So if I would plug a negative x into my original function, it's going to equal the exact same thing as the original function.
Okay.
So that's why that's the only thing you need to do for these problems.
Right.
See what f of negative x is equal to.
Okay.
And if it equals the exact same thing as f of x, so in this case f of negative x equaled the same thing as f of x,
Okay.
right? When f of negative x equaled the same thing as f of x, then I know it's an even function.
Okay. That makes sense.
Okay? Let me do a quick example to Kylo's question. Okay? New problem right now. Okay? F of x, you don't need to do this, but you're welcome to write it down. X squared minus 2x plus 5. If that's on there or not. Guys, help me out a little bit. So if I were going to test to see whether this one was even, odd, or neither, so again, I'm going to do this, right? So that'd be negative x squared minus 2 times negative x plus 5. Negative x times negative x would be a positive x squared. Negative 2 times negative x would be a plus 2x. Plus my 5. Is this the exact same thing as the original? No, it's slightly different. Therefore, this function, it's not even. It's also not odd. So this one would be neither. Okay? So don't just automatically assume if I see an even power, it's going to be an even function. The reason, the real trick to it, okay, look at all the powers on the variables for x. Here's an even, here's an odd. When you have one of each, it's going to be neither. If you only had even powers, like this one, it'll be even. Okay? Now it doesn't, and then I'll show you the next one here in a second, you'll see. But, so, anyway, just so you.
Do an even.
Alright?
So if you have like the same setup,
That's even,
but
like,
if you have
not
one
two
positive,
of
one negative, then it's going to be neither.
2x is square root of 2. So it's square root.
One positive, one negative.
Yeah, like out of your two answers, when you're comparing the two, how they're not equal, like in the last one,
But
since you have
2x
like
is
one of them is a
Oh yeah, they're not the same.
right.
Yeah, whether it's positive or negative or a different number, I mean, they have to be exactly the same for it to be even.
Okay.
Or it has to be exactly the opposite. It's got to be the opposite of it to be odd. Okay? What's the opposite of x squared minus 2x plus 5? What's the opposite of x squared minus 2x plus 5?
Flip the signs.
Negative x squared
Plus 2.
plus 2x minus 5. Okay? The opposite of a function means every term is its opposite, right?
And this one's odd.
That's when it's odd. Okay? But this one's neither, because it's not opposite and it's not the same.
Right.
So therefore it's neither. Okay? Alright, so let's check this one. So again, you do the same thing every time. I'm going to plug negative x into my function. So 2 times negative x cubed minus 4 times negative x plus 1. When I take a negative x times itself 3 times, negative x times negative x times negative x, what do you get? Negative x cubed, right?
Yep.
What's 2 times negative x cubed? Negative 2x cubed. Okay? Minus 4 times negative x
4x
plus 4x. And then plus 1, right? Okay. Is this the same as this one?
No.
No. Is this the opposite of this one?
No.
Not quite. Okay? So therefore this one is neither. Okay? Now, had this not been there, so that wouldn't be there, so that wouldn't be there.
Then it would be odd.
Now, what is type of function is it?
It's odd.
It's an odd function because this is exactly the opposite of this. Do you see that?
Yeah.
The opposite of 2x cubed minus 4x would be negative 2x cubed plus 4x. So had the function been this one, then you would have said odd. But we had a plus 1 back here, and that plus 1 never switched to its opposite, so therefore the answer was neither. Okay? So to determine whether or not a function is even, odd, or neither, you're just going to plug in a negative x into the function and see if you get the same thing, which would make it even. See if you get the exact opposite, which would make it odd. And if neither of those things happen, then it's neither. It's not symmetric. What questions do you have? Do you want to see one that is odd? Do you want to see me work it out? Do you want to see another even one? Do you want to just make up your own function and have me do it and talk through it? What do you need right now? Yes?
I'm confused about, so like when you did 2 times negative x cubed, like why doesn't the cube go away? Like that doesn't make sense to me. Like it like stays in the problem after you cube it.
So when you take negative x times itself 3 times, so negative x times negative x times negative x, you get a negative x cubed, right? It'd be like saying when you take a negative 2 times a negative 2 times a negative 2, you get a negative 2 cubed, which you know that answer is negative 8. Yeah. Okay? But we don't know what x is, so we can't actually simplify it, right? So when I take a negative x times a negative x times a negative x, I get a negative x cubed. Okay? Which then I'm taking 2 times that, and 2 times a negative number would be a negative 2x cubed. Alright? Okay. The last 4 problems, I don't know what numbers they are, okay, but the last 4 problems on standard 16 are just this. Is the function even? Is it odd? Is it neither? Okay? Try and do those 4 for Monday. We'll finish talking about it. I'll pass back your quizzes, and that's the plan.
When do you think this test will be?